Okay, good evening. Ready to go, Homer? Okay, thank you for the people in the room. Thank you for your attendance and your support for the event. I'm Jeff Bird, and with Omer Majid, we're co-chairs of the Ottawa Canadian Aeronautics and Space Institute, the Ottawa branch. And so we've organized this talk with a colleague from AIAA branch that we have become enamored with in terms of his knowledge and his background. And we looked for a topic that Walter was passionate about, and so the virtual people will listen to this, will follow your questions on chat. I think Walter would, unless there's a burning question, he will like to finish his presentation, and then we'll do questions at the end. But there may be some questions that are too important and too passionate to be able to do without. So without further ado, thank you for coming to this CASI event. And if you're not a CASI member already, do go to casi.ca and look for joining. And if you're here, give us some ideas on other things that we can do, talks that you can have. So the students are most welcome and encouraged to give us things that they would like to hear about. And I pass the mic to Omer to do the introduction for Walter Gordon, our speaker. Thank you.
Okay. Thank you, Jeff, for the CASI intro. And I have the honor to introduce our guest speaker, who has driven all the way from Buffalo on a rainy, gray day to speak. Walter has worked as an engineer in Western New York from 1979 to 2020 in 4 different aerospace firms. And his last position was as a business development manager for Moog Space and Defense Group. And in parallel, because he wasn't busy enough, he was also a reserve pilot of Hercules aircraft over 30 years in the United States Air Force Reserve. And he served as commander as well of the 328th Airlift Squadron and the 914th Airlift Wing in Niagara Falls. And that's on the US side of the border. He's a veteran of Operation Desert Storm and Iraqi Freedom, and has over 2,000 flying hours on the C-130. He is evidently passionate about aviation and aerospace. He joined AIAA at the tender age of 17, and he's currently chairman of the Niagara Frontier section. He's also a member of the History Committee, and he is chairman of the Niagara Frontier Aviation and Space Hall of Fame. Also past president of the Niagara Aerospace Museum and Aero Club of Buffalo. He has Bachelor of Science and Master of Science degrees in aerospace engineering from the University of Buffalo, as well as a Master of Science in Strategic Studies from the U.S. Air Force Air War College. And I also have come to believe that Walter is secretly Canadian. Because he told us, he confided to us today, that he much prefers to watch the snowbirds than the Thunderbirds or the US Blue Angels. I mean, and he's going to talk about our iconic aircraft, the Avro Arrows. So honestly, we're going to work on your citizenship application, right? Okay, without further ado, please join me in warmly welcoming Walter Gordon.
Bear with me for a second while I put this on and try and share my slides. And remember to share the sound. I don't have any movies, but I do have some sound. Okay. And I tend to walk around, so apologies in advance to people in the Zoom if I disappear, and to you too if I trip over something because I don't know where I am. So, and I may take my glasses on and off because these are brand new glasses and I'm not used to them yet. I may put them back on. So once there was an arrow, I want to point out to everybody the new logo. I developed this myself of the Niagara Frontier section since we included Eastern Ontario and Quebec. So you have the Bell X1 on one side and you have the arrow on the other side. I think the two greatest aerospace achievements of the area. I don't know if AIAA National has signed off on that yet, but that's our logo. So let's talk about see this. I've lost. There we go. Sometimes I lose track of the mouse. So there it is. That's the first arrow, RL-201. Mach 2 air defense interceptor. January 54, the contract was let, rolls out only 3 years later, and the first flight was less than 2 years after that. So a very compressed timeline, which you'll appreciate even more when I talk about the origins of Avro Canada that made this aircraft. Origins of Avro Canada. 1938, they made rail cars. It was National Steel Car. They made railroad cars, but then they started building aircraft under license from the designs in the UK, the Westland Lysander and the Avro Anson. These are metal, wood, and fabric aircraft. Here's a Lysander, and here's an Anson. And even then, the engines were not manufactured in Canada. The Canadian aerospace industry did not have the technology to make a state-of-the-art aircraft engine back then. They were imported from the UK and the US. When World War II started, at least with respect to the British Commonwealth, National Railcar was nationalized as Victory Aircraft, and they started making Avro Lancasters under license. Kind of state-of-the-art bomber for World War II, but again, Victory Aircraft was just making them under license. It was a UK design, and as well, the engines were still built in the US. Canada did not have the capability at the time to build a state-of-the-art aircraft engine. In this case, the Merlin that was used in the Lancaster and the P-51 and the Spitfire. World War II ends. The staff is cut from 10,000 to 400. The government sells Victory Aircraft to the Hawker Siddeley Group in UK, and it becomes Avro Canada. They made some significant hires, which you're going to hear more about. Jim Floyd from the UK and James Chamberlain. Can someone tell me how to pronounce the name of that aircraft company? Because Nordyne. I always mess it up. Thank you. I will remember it now. And I've never said it, Nordyne. So what was the first thing they worked on? Air Canada, TCA, Trans-Canada Airlines then, they had a requirement for a medium-range jet transport. Avro Canada responds with a C-102 jetliner with Jim Floyd as the chief engineer and Jim Chamberlain as the chief aerodynamicist. Here's a picture of it. It's actually a beautiful aircraft. So this is first flight in 1949. It was originally supposed to have just 2 engines, but the engines that they wanted weren't available yet. They weren't powerful enough, so they went with 4. Here is a picture. I'm kind of at a loss to explain the costumes. I think they're getting ready to take off for their initial flight from Toronto to New York, and it was some sort of send-off party. So it was the first jet airliner to fly in North America. In fact, it was almost the first airliner to fly in the world. The de Havilland Comet in the UK only beat it by 13 days. If they flew 2 weeks earlier to the day, it would have been the first jet airliner to fly in the entire world. April 18th, 1950, they fly from Toronto to New York in 1 hour, and they carried the first jet airmail in North America on that flight. And obsessive that I am, I bought several canceled envelopes that were on that flight. And this is one of them. This was on that flight, first jet airmail in North America on the jetliner. And you guys can take a look at that if you want to pass it around. There are still a couple of those available on eBay, and they're not that expensive if you want to buy a little bit of Canadian aerospace history. Trans-Canada backs out. Some American airlines express interest. Howard Hughes, who ran TWA at the plane, the older people probably remember who Howard Hughes was, loved the airplane. He was a pilot, and Avro flew it out to California where he was, and he flew the aircraft extensively, and TWA was probably going to buy them when the Korean War kicked off. And Avro Canada had a parallel program of the CF-100 Canuck, which I'm going to talk about, the Clunk, and C.D. Howe, who was called the Canadian Minister of Everything at the time, he ordered the jetliner program terminated to focus Avro on CF-100 production. It was used as a chase for the CF-100 development, declared surplus in 1956, And sort of as a predecessor for the Arrow story, it was cut up and sold for scrap. I don't know what it is with you people. Only one. They only made one jetliner and they cut it up. And you can read this. This was the test pilot who flew it most extensively. I can't imagine anything more unpleasant than seeing an airplane you have lived with for 7 years and enjoyed flying, a really beautiful machine being cut up with saws, axes, and hammers with pieces falling on the hangar floor. And there's a painting of it. And it really is beautiful plane, beautiful plane. I want to make a little contrast here. Oh, by the way, the nose section does remain. This is actually at the museum here in Ottawa, but it's not out on the main floor. It's on the storage facility. So if you want to see that, you have to get a special tour. You have to get a special tour. What is this? Yeah, RJ100. So let's compare the RJ100, the CRJ100 with the CO102, 1949 to 1991. Similar passengers, slightly less payload, heavier empty weight, and I'll talk to why that is a little bit, heavier gross weight, similar cruise speeds and similar ranges, 1949 versus 1991. And of course, the biggest difference in those planes was this engine here in the jetliner, a centrifugal thrust engine that, as we were talking at our table, Frank Whittle could have cuddled up to, versus these GE CF-34s. And if you look at the weight and the thrust and the performance of the two different engines, 4 of the Derwents in the jetliner and 2 of the CF-34s, that accounts for most of the difference in weight and performance, especially when you take into account the specific fuel consumption of the engines. So really, you know, with some differences that are mostly explained by the engines, you know, Jim Floyd and Jim Chamberlain made something pretty darn similar to the CRJ-100 in 1949 at Avro, Canada. So let's move on to the CF-100. RCAF has a requirement for an air defense interceptor. They want to stop those Soviet bombers coming over the north. Need an advanced radar to do this, needs a pilot and a nav, so it's got to be bigger, it's got to be 2-seat. We want to be able to climb quickly and fly out over the north to shoot down those bombers without running out of gas. So it's a pretty stringent requirement. Avro was awarded the contract in October of 46, and the first flight was in January of 1950. And here's a picture of a pair of Canucks. They also referred to it as the clunk. And I hear that was because of the noise the landing gear made. When you raised it, it would clunk. So they called the airplanes the clunk. The first ones had Rolls-Royce engines, but production models had a Canadian engine, the Avro Orenda. And I'm going to get to that in a little bit too. Almost 700 of them were produced. Most of them were in service with the RCAF, extensive service in Europe. Belgium also bought a small number, and it served until 1981, not too far from here in North Bay. And there's a picture. If you go to North Bay today, you can see one on a stick, and I'm sure there's one in the museum. Okay, so Orenda engines, how did that come about? Canadian NRC staff visits the UK to study the Whittle engine. Turbo Research is created as a Crown corporation, and at the end of the war, just like Victory Aircraft, it's sold to Avro Canada as their gas turbine division. The first Canadian jet engine they make is a Chinook. It's axial, so obviously it is not a copy of the Whittle engine. It's a completely different design, and it evolves into the more powerful Orenda engine that powered the CF-100s. Over 4,000 of them were manufactured for the CF-100 and the CF-86, manufactured by Canadair over in Montreal. In 1955, that gas turbine division was named Orenda Engines after the very famous and very successful engine. And here's a picture of the a CF-86 powered by one of those engines. And from what I've read, the CF-86 was generally considered the best air-to-air combat F-86. And I think in large part due to the Orenda engine, the thrust to weight and so forth, it was considered a better aircraft than the ones with American engines. Okay, so finally, we're going to talk about the Arrow. The Soviet bombers are getting faster, they're flying higher. The RCAF says we need something to replace the CF-100. They come up with this specification, Air 7-3 in 1953, 2-seat twin engine, all-weather, long range. Okay, so far, we're still kind of talking about the CF-100. Internal weapons bay, the size of B-29 bomb bay. They knew this was going to take very big missiles to reach out and get those Soviet bombers. Mach 2+. And this is a biggie, sustain Mach 1.5 in a 2G turn at 50,000 feet. For the aerodynamicists in the room, that's hard. you know, because there's no air up there, and you start pulling those G's, the airspeed bleeds right off. But they wanted to be able to sustain that. So that means powerful engines and a very big wing. And you can read this. This was the assistant to the Avro CEO. At the time, there were many American engineering teams who said they wouldn't even try to meet this spec, and we were off our rocker to even try. So the timeline, January 1954, the Department of Defense Production issues a contract for 2 prototypes, but that was soon changed to 11 pre-production via the American Cook-Craigie method. And this is a very significant change in the Arrow story. When you make prototypes, you basically don't make any tooling. You make the airplanes by hand, you fly the prototypes, and you see what you want to change, and then you change it, and then you make the production tooling. Cook-Craigie, you do a lot more of the design and test work up front. So those first airplanes you build are pre-production aircraft made with production tooling. Why would you want to do that? Because you get to a production airplane sooner if that's all you make is a production airplane versus iterating through a prototype process. So on the one hand, that sounds smart, but the disadvantage is that much more of the cost is front-end loaded because you have to do so much detailed design work up front. So you get the airplane sooner, but you're spending a lot more money sooner. Engine choice. Originally, it was going to be a Rolls-Royce engine from the UK, the RB106. They ended up canceling that engine. It wasn't made. Then they went to Curtiss-Wright in the US. We're going to use their J67. That was canceled. The US and Curtiss-Wright canceled that engine. So then they said, okay, we're going to start out with the Pratt & Whitney J75. This is the engine that was used in the F-105 Thunder Chief, for those who are familiar with that aircraft. But that's not good enough for the Arrow. So we're going to put, RCAF is going to put Orenda under contract to make this new engine, the PS-13 Iroquois, which is going to be better than the J75. So the first couple of Arrows are going to fly with J75s, but then as soon as possible, we're going to switch over to this Canadian engine made in-house by Orenda, the Iroquois. It's going to be fly-by-wire, single string analog. So, you know, later aircraft were duplex or even triplex, but single string analog with a mechanical backup, damping and roll, pitch and yaw, which was new. Mostly we only had yaw dampers at that point, with automatic turn coordination and adverse yaw reduction. And fly-by-wire in 1957, 58, 59 was a really big deal. No one had done it before except for some sort of trivial demonstrators in the 30s and 40s using propeller aircraft. And if you look at this timeline, you'll see what I'm talking about. Nothing else flew that was fly-by-wire until the Bell Lunar Landing Research Vehicle in 1964. And for those of you who might be familiar with it, not that this makes it any easier, but that's not an aircraft at all. It was a flying vertical takeoff and landing flight simulator that simulated the lunar module. And that was made right across the border by Bell in Niagara Falls. Neil Armstrong actually went on record as saying he didn't think he would have been able to safely land on the moon without the training he had in that vehicle here on Earth. But that was the second flying fly-by-wire aircraft, even though it was not an airplane. And then the US Air Force put it in a B-47, the Concorde in 69, and then the first tactical fighter fly-by-wire wasn't the F-16 prototype, the YF-16, until 1974. That's how far ahead of their time they were with analog fly-by-wire. And incidentally, these were all analog too in the Arrow. The F-16 didn't go to digital fly-by-wire until the C&D model, if I'm not mistaken. They said, fire control and armament system. Initially, we're going to use an American system, this MX-1179 and Falcon missiles. By the way, Falcon missiles were crap. The US used them extensively at the beginning of the Vietnam War. They were almost totally ineffective. The RCAF wisely, but expensively says, that's not good enough. We're not going to use this American stuff. We're going to give a contract to RCA for a new Astra fire control system, and we're going to buy into this active Sparrow missile that the Navy is making. And when the Navy drops the Sparrow, the RCAF says, okay, we're going to pay for it and continue the program. So let me just stay on this slide for a minute. So right now, they're building a new airplane via Cook-Craigie. So more front-end costs loaded upfront with a new radar that they're going to pay for, a new engine, and a new missile. All of this is new and paid for by the Canadian government during Arrow development. Wind tunnel testing, National Aeronautical Establishment in Ottawa. So these are the different places where it was tested. I'm wondering if anyone in this room can tell me, because I don't know. This is what the Arrow used, the 6 by 10 foot subsonic at NAE. Is that now the NRC 2 by 3 meter? Does anybody know? Because I don't. The sizes seem similar. I suspect it probably is. In the US, it was tested in the 8-foot transonic tunnel at Cornell Aeronautical Laboratory. That's now Calspan's tunnel. Tested at Langley, and the Iroquois engine was tested at NASA Lewis and the Arnold Engineering Air Development Center in Tullahoma, Tennessee. So definitely a cross-border thing with respect to testing. They also made free flight models to test over Lake Ontario. And when you're looking at here is a Nike first stage. It's the first stage of a surface-to-air missile with a highly instrumented Arrow model in the front end. And they fired those out over Lake Ontario. The Nike booster would separate from the model, and then they would gather data via telemetry on this flying model. And some of you may have heard that there have been repeated attempts to try and find those models in Lake Ontario within the past 5 to 20 years. And to the best of my knowledge, they have not recovered any. They recovered some simple darts. Is it the shape of an arrow, or is it just like a dart? You know? Yeah. Because to my knowledge, that's what they've recovered. It was part of the Arrow program, but it wasn't the full aerodynamic shape of the Arrow. So I think that's the real prize that they still hope to find. So the CF-105 was rolled out on October 4th, 1957. The Canadian Minister of National Defense was there, Chief of the Air Staff. Dobson, Crawford Gordon, and Fred Smythe were all Avro people. Crawford Gordon was the head of Avro Canada. Roy Dobson was the head of the Hawker Siddeley Group back in the UK. Senior US Air Force staff, and John Alexander Douglas McCurdy. Now no one say anything. When I first gave this talk, it was at an AIAA SciTech conference in San Diego 4 or 5 years ago. And there was a surprising number of people in the room. And I said, okay, Canadians don't say anything. Who is J.A.D. McCurdy? Crickets. Crickets. I said, okay, Canadians, tell them who he was. Crickets. I couldn't believe it. So those people who know, tell those people who don't know, who is J.A.D. McCurdy?
First Canadian pilot.
Right, first person to fly an aircraft in Canada. First person to fly an aircraft in Canada in 1909 on frozen Bedeck Lake in Nova Scotia. And he was much older now, obviously, and he was at the Canadian rollout. Incidentally, the Silver Dart, most of you may know this, the Silver Dart that he flew on Bedeck Lake was built and first flown in Hammondsport, New York, by Glenn Curtis and McCurdy and other folks. So in the AIAA Niagara Frontier section. And here it is. There it is, the Arrow, beautiful airplane, very, very big. If you look at the size of the people next to it, and the crowd, of course, is much, much bigger than this. So huge news in Canada. So, of course, the headline in Toronto the next day is at the Globe and Mail, Russia launched its first satellite. It was terrible, terrible luck. They were surprised by Sputnik. So you have a picture of the Arrow, but all the words on the cover of the paper are about Sputnik. So let's talk about the flight test a little bit. How am I doing for time? Oh, I'm doing good. First flight was March 25th, 1958. And what I have here is a radio recording of that first flight. There was a guy there and he's reporting on it over the radio. People out in Zoom land, when I've given this talk before, I tell them, okay, this is a radio recording, and I start it. And within 10 or 15 seconds, people are typing in the chat, there's no video. So there's no video. This is a radio recording. So imagine yourself in your living room listening to this in 1958.
It's coming up now, slowly
Is it coming out?
taxiing southwards.
I hear it on the audio through Zoom.
But why isn't it coming out here? I'm going to turn off my headset. I did share the sound. Let's try it again.
It's coming up now, slowly taxiing southwards towards the end of a 2-mile runway. I can see Avro's famous test pilot, Jan Zarakovsky, looking small under the canopy of this great long aircraft. It's rather difficult to imagine how this aircraft will fly, because from this angle, as I look at the side fuselage, it does not appear to have wings, only a large, high tail. It's continuing its taxiing down the runway, very quietly, by the way. Very little noise from the motor. Now the plane has disappeared over a small hummock which obscures my view of the end of the runway. So I suppose in any moment we can expect the CF-105, the Avro Arrow, to come rushing up the runway and take off. I hear a sound. This is it. This is it. Here she comes. It's off the ground. That's it. What a magnificent and thrilling sight. Like a great dart taking to the air at a 45-degree angle, followed by the 2 chase planes.
I've listened to that a bunch of times. It's 2 years before I was born, and it still gives me chills when I listen to it. It's just, I can't imagine being there or being a Canadian at that time. And the one on that first flight, basically flawless. 35 minutes, single right up, nose gear warning light due to a faulty micro switch. Exceeds speed of sound on the 3rd flight. The 7th flight, it goes Mach 1.52. And at the time, there was a hotline between an RCAF radar station that was watching this region, live hotline. So whatever the controllers were saying was broadcast in the control room where they were supervising these things at Avro. So they, it was easy for them to coordinate. And they overheard the RCF radar operator observing this Mach 1.52 flight. He had never seen anything go up. Probably all he ever saw before were CF-86s. And here's this thing blowing across the screen, practically at twice the speed he's ever seen before. November 11th, Spud Pataki flew it up to Mach 1.98 at 50,000 feet. That was the maximum speed ever achieved by the Arrow. And it was flown by 3 Avro test pilots and 1 RCAF pilot. This is a flight report from Flight Lieutenant Jack Woodman, the RCAF pilot. And you guys, I'll just give you a minute to read that. But he liked the airplane, thought it handled very well. Incidentally, after the Arrow was canceled, and I didn't learn this until a week or so ago preparing for this talk, because I'm kind of in awe to be giving it here in Ottawa to you guys. When the Arrow was canceled, Woodman went to the US and got a job with Lockheed, and he became one of their chief test pilots. And when Lockheed came out with the L-1011, he was the chief test pilot on the L-1011, ringing it out and flying it all over the world, selling it. And obviously, the L-1011 was a terrific airplane, much better than the DC-10, if you ask me. Anyway, so let's talk about the engines. The first 5 Arrows were Arrow Mark 1s. They were powered by these Pratt & Whitney J75s that we were talking about. This is a 6,000-pound engine, 16,500 in military, 23,500 in max afterburner. Do you guys say reheat up here, or do you say afterburner? Afterburner, okay. The next tranche of aircraft, the Mark II, starting with number 6, was to have the Iroquois. So it weighs almost 1,500 pounds less. And in Max AB, it has over 2,000 pounds more thrust. So 2 engines together in the airplane, 3,000 pounds less weight and 4,000 pounds more thrust. So you're going to have a lot less drag, the L over D, et cetera, et cetera. And they were hoping that, and I think I talked to this on a subsequent slide, that RL-206 with that engine was going to get the world airspeed record for Canada. So the Iroquois first flight was on November 13th, 1958 in a Canadair CL-52. And I'd be surprised if anyone ever heard of a Canadair CL-52. So you say, looks a lot like a B-47 to me. And it is. It's a Boeing B-47 that was loaned to Canada by the United States Air Force. And that is the only time in history. We were talking at my table earlier about the close cooperation that the US and Canada always had and still have, by virtue of NORAD. This is the only time in history that one country ever loaned another country a nuclear capable jet bomber. Here you go. Because that's what this thing was designed to do, was nuke Moscow with aerial refueling. So how is this thing different from a regular B-47? Well, if you look there, they don't normally have a gigantic engine attached to the rear of the fuselage. That is the Iroquois. And they did the test flying by attaching it to the fuselage of this B-47. And here's another view from the side. Here's the regular B-47 engine. I think it's a J-57, 5,200 pounds of thrust. There's 6 of those on it. And there's the Arenda, the Iroquois, with 25,600 pounds of thrust. So when that thing was cooking in full afterburner, which I suspected probably could not do in this flight test arrangement, it was making as much thrust as 5 of the 6 other engines on the airplane put together. Here's another picture that, again, I just encountered preparing for this talk. I never saw it before, which really gives you an appreciation of how massive that engine is on the back of the B-47. So that was how they tested it, you engine test folks, before the Arrow was ready to fly with it. Meanwhile, storm clouds. 1957, the US and Canada create NORAD, North American Air Defense Command, with a 4-star US general commander and a 3-star Canadian deputy commander. And of course, that is the case to this day. NORAD today in Colorado Springs, I don't know who it is today, but it's a Canadian 3-star, is the number 2 guy in the defense of the US and Canada. They have an incentive at this point, you might say a pressure to integrate their forces, command and control certainly, and weapon systems to a certain extent. However, Partridge and Sleeman are both Arrow advocates. They realize how important this fighter will be to the newly created NORAD. Shortly after the creation of NORAD, Prime Minister Diefenbaker gives a speech to Parliament. The number of interceptors required will be less than forecast, if in fact they will be required at all in the 1960s. And this was not a philosophy that was unique to Canada. I believe in the UK, it was called the White Paper, that said manned interceptors are going to be obsolete. All we need are surface-to-air missiles to defend ourselves against bombers. So we're going to stand up 2 Beaumark squadrons, which is a gigantic US ramjet-powered surface-to-air missile made by Boeing. Again, kind of like the Falcon missile, crap, but it was the best they had at the time. We're going to install US semi-automatic ground, I guess SAGE equipment is redundant, semi-automatic ground equipment in the Canadian air defense system. But most importantly, the Prime Minister says it's not advisable to put the CF-105 into production at this time. However, we're going to continue development pending a review in March. So these dates are very important. So this is September 23rd, 1958. We're going to continue Arrow development pending a review in March of 1959. But meanwhile, we're going to cancel the Astra and the Sparrow 2, and the 105 is going to use US systems instead, presumably the lesser ones that the RCAF forced Avro to switch to earlier in the program. Again, cost. So these are some cabinet minutes, classified secret at the time, obviously since unclassified, 1958. So this is the day before John Diefenbaker made that speech, excuse me. Minister of National Defense expressed the view that if, as seemed likely, the Arrow development would be terminated by the end of March. December 22nd, same guy, it was still his understanding that Arrow and Iroquois development will be terminated by March 31st. Now, Diefenbaker made this speech. This is going to continue pending a review in March. December 31st, Diefenbaker asks whether any member of the cabinet wished to change the decision which had been made on the Arrow program, And then finally, on January 29th, the Minister of Finance says, as soon as we publish our figures, people are going to see that there ain't no money in the budget for the Arrow except to cancel it. So on February 20th, still, depending on what part of March we're talking about, 2, 3, 4 weeks before the decision that was going to be made in March, the Prime Minister makes a speech to Parliament. As foreshadowed in the speech I gave on September 23rd, we're going to terminate Arrow aircraft and Iroquois engine development now. And the US is going to help us buy Beaumarks and pay for SAGE. Beaumarks is going to have US nuclear warheads, which never happened. And this was the headline the next day. In Malton, Ontario, they actually received, I think it was a telex at the time, saying stop all work now. Now, immediately. No more work on the Arrow, no more work on the Iroquois. So here's one of the headlines. Here's another. No other work for makers of Arrow or engines. And then finally in Windsor, across the street from Detroit, for 13,000 economic disaster. So 14,000, and this is Black Friday. We were talking about Black Friday at our table, February 20th, 1959, 14,000 Arrow and Arenda employees were let go that day. Soon another 10,000 at subcontractors, some of which were in the US, but most of which were in Canada, in Eastern Canada. And the press that the Prime Minister received on this was so terrible. He said, look, the Avro management knew it was coming. I won't say they knew the exact date, but they knew what the decision was and that it was unchangeable. Now, unless there was some secret communication between the government and Arrow that me and a jillion other Arrow lunatics haven't been able to uncover, this is a lie. This is a bold-faced lie. And of course, this is 1959. This was before a certain US president said, you know, it's okay to lie all you want. Anyway. These were ads in a local paper. This wasn't a big paper. This was a local paper in and around Toronto. Former AV Row employee, any class of work, willing to try anything, work of any kind, will consider any job. I mean, it's just sad. And there were hundreds of these ads. So what of the aircraft? They finished 5 of them with the J-75 engines. They were completed and flown. 1 Mark II with the Iroquois was complete. Anticipating, some places say it was going to fly in 2 weeks. Some say it was going to be 10 weeks. You'll read a lot of Arrowheads. Those are Arrow enthusiasts saying, you know, when it was canceled, they just should have taken that one up that day and flown it and said, look how amazing it is with the Iroquois engine. But I honestly think it wasn't ready. My personal opinion, I don't think it was ready to fly. Many anticipated it would set the world speed record, and it probably would have. I think the max speed that the Arrow achieved at the time, 1.98, with a standard atmosphere at 50,000 feet, that works out to about 1,300 miles per hour. And the speed record at the time was set by an F-104 prototype. It was 1,404 miles per hour. So to break the record, they would have needed 100 more miles per hour. So 3,000 pounds less weight, 4,000 pounds more thrust. I don't know, I haven't run the numbers or anything, but it seems there would have been a good chance. And there were many others in various stages of manufacture. So what are we going to do with them? Air Marshal Campbell, this was an Arrow proponent, he writes a memo, disposal of material. We could give them to the Crown Assets Disposal Agency. This course is not recommended. Almost anything could happen then. The airframe and engine could conceivably be placed on public view or even in fact used as a roadside stand. This, I'm sure you will agree, is most undesirable. So option B, relinquishing any Department of National Defense interest in the airplane, send them to DDP. I forgot what that stands for disposal. In this case, DDP can reduce it to scrap. This course is recommended. I appreciate being advised, Hugh Campbell, Air Marshal, Chief of the Air Staff. And that's what they did. This is the flight line. You can see 4 of the aircraft there. The one closest to us, I believe, is RL 205. And if I zoom up the picture, you can see that they've already cut it to pieces. They've already cut it to pieces. Today, there is not much left. This is the nose of RL 206, the Mark II that was going to fly with the Iroquois engine. It's only a couple of miles from here in the museum. And you can see where they just cut it with torches. I took these pictures myself a couple of years ago. In fact, if you get close and if you look right there, it says cut here in grease pencil. That's still there in the museum. You can go look at that tomorrow if you want to. And you can see the jagged edge that they cut with a welding torch to cut these airplanes in half. The outer wing panels of 203 are also at the museum, but they're in the back storage facility with the nose section of the jetliner. So these are the outer wings of 203, and that's it. I mean, I'm sure there are some little pieces and some valves and so forth otherwhere, but these are the only big pieces that are left. There's also an Iroquois in the museum next to a J75. It's just cut off out of the picture, but the engine and back of it is a J75, so you can compare them. And I happened to take this picture. I thought it was pretty neat, showing the variable nozzle in the back and how complex it was. Why? The Canadian government wasn't alone in believing that we weren't going to have manned interceptors anymore. The US canceled an advanced version of the F-106 Delta Dart, the C&D model. They canceled the F-108, which was going to be a Mach 3 fighter made by North American. The UK, the F-155. And what was the other UK fighter we heard about earlier? The TR-2? PSR-2, also canceled. It was enormously expensive. The decision to design and build a new engine, new fire control system and missile, and the airframe made it very, very expensive, especially when they went Cook-Craigie and front-end loaded that cost. They just thought it was going to cost too much. The defense staff, because of that, they agreed on the condition that they buy a substitute US aircraft. And this is, you all can read this, it's kind of long. But I think this is the reason. John McClin wrote this in a book, Canada's Changing Defense Policy in 1967. And I think he hits the nail right on the head, that it was just to make all of those pieces of a state-of-the-art fighter at that time, it was just more than Canada could afford and still do everything else they were doing. You know, if they stuck with an imported engine, an imported radar, and an imported missile, and of course, those things all did get better over time, maybe it would have been able to proceed. And in fact, later versions of the J75, they didn't get any lighter, but they got a lot more thrust. Eventually, they exceeded the thrust of the Iroquois. Aftermath, Diefenbaker government is voted out. The Beaumarks are deactivated junk. RCAF acquires F-101Bs. These were unacceptable when the Aerospec was written in 1954. And they got them in 1961, and they were flown until they were replaced by CF-18s. I think they were still flying them out of North Bay until the early 80s, if I remember correctly. Arrows to the Moon. This is actually a title of a book. 25 to 30 Arrow engineers who were immediately hired by NASA and NASA subcontractors to work on the US space program. And two that I'm particularly partial to is Jim Chamberlain. I also give a talk on the Gemini program, and Jim Chamberlain, the chief aerodynamicist for the Arrow, was the first program manager for Project Gemini. I mean, Gemini was the next US space program after Mercury and before Apollo. It did all the risk reduction that was required of Apollo. And Jim Chamberlain from Canada, from the Avro Hour program, was running it during the first couple of years. John Hodge, I think he was a young engineer, did load analysis on the Arrow. He became the second US NASA flight director after Chris Kraft. All of you have heard of Gene Kranz. You know, if you've seen Apollo 13, failure is not an option. John Hodge was Gene Kranz's boss, And he came over from the from the Arrow program. In fact, on Gemini 8, which most of you are not familiar with, it was the first docking in space of the Gemini capsule with an Agena docking vehicle. They had a stuck thruster, and the Gemini started to spin out of control till Neil Armstrong figured out what was going wrong and stopped it. John Hodge was on duty during that entire incident and was responsible for bringing them safely back to the Earth. Arrow engineer. I actually interviewed him over the phone before he passed away. So just to put the whole program in context, it didn't fly a ton. These are the 5 aircraft. You can see how many flights they made and how many hours there were. Number 5, it had one flight, 7/10 of an hour. It was flown by 4 pilots, 3 Avro test pilots, and then Jack Woodman was the RCAF officer that I mentioned. Total Arrow flight time over all the aircraft, 70 hours. First flight was March of 1958, and the last flight was 11 months later, February of 1959. Arrow in the past 60 years, dozens of books, countless articles, some recommended reading. There were 2 books published by this group called the Arrowheads. Boston Mills Press does not exist anymore. They have another name, but if you Google Boston Mills Press, you'll find them. These books aren't actually in print, but you can get new and used copies, from Amazon or whatever. This, if you were going to get one book about the Arrow, this is the most comprehensive and objective one that I have come across. If you really want to geek out on the Arrow, this is another one that they published. This is the actual flight manual and deployment basing plans. So you can read about the checklists that they developed to fly the airplane and where in Canada they were going to put them and operate them. It's pretty cool. For the people who are in the room, I have both of these books right here. So feel free to look at them when we're done with the talk. There was a CB miniseries, The Arrow with Dan Aykroyd. If you haven't seen it, it's a 2-part miniseries. You can actually watch it for free on YouTube. They have a low resolution. It's like 480 pixels. You can actually watch it on YouTube for free. I first saw it on YouTube, and then I found some DVDs here in Canada and ordered them back to the US. It's good drama. It's a fun movie. It's lousy history. It's lousy history, but it's fun. It's fun. And you get to see footage of the Arrow and some Arrow radio control models flying, and it's very dramatic, and it's a lot of fun. My biggest objection to it, I think I've already told you how much I admire Jim Chamberlain, the chief aerodynamicist Gemini program. They show Jim Chamberlain inventing the area rule in the movie instead of Dick Whitcomb to lower transonic drag. And it's like, no, as an aerospace engineer, I can't bear that. I can't bear that. Many conspiracy theories that were fed by the decision to scrap the aircraft. Some people think there was pressure from the US to scrap the aircraft, that the Arrow was going to be so good that it would get overseas sales instead of the US aircraft manufacturers, and that maybe was the reason. There's a belief that one got away and still survives. I have read, I don't remember the guy's name, but the story goes that there's a University of Toronto history professor that in one of his classes, he looks at his students and he says, it's true. One did get away. They keep it in a barn in Saskatchewan. And once a year, it's taken out and flown by Elvis. Recovery of the flight models from Lake Ontario, we already talked to that. And about 10 years ago, there was a proposal, and I have a number of newspaper articles about this on my hard drive, to replace the CF-18 instead of the F-35 with a modernized Arrow. And it was actually endorsed by a Canadian 2-star. I don't think he was Air Force. I think he was Army. And this is a diagram from one of the newspaper articles. And I think, I love the Arrow. I love the Arrow, but this is stupid. I mean, it's a 1959 airplane. It's an interceptor built with the technology of the time. And I am something of a Canada-phile. I truly think you all made the right decision in deciding to buy the F-35. Certainly not to try and resurrect the Arrow. So Avro Canada, how did they do it? How did they go? Oops, sorry, I didn't want to show you that bit. How did they go from making Lancaster bombers to the most advanced airplane in the world, basically, from 1945 to 1958, 13 years? Oh, no, I'm good. Thank you. Being offered some juice. So Jim Floyd, when he was given an aerospace award, it wasn't by CASI, it was by someone else in 2009, he talks to a placard that he had on his desk at Malton during those years when he was the chief engineer on the jetliner and the Canuck, and then the vice president of the company during the development of the Arrow. And it said, if something seems worthwhile, but it's obviously impossible, do it anyway, which I thought was pretty neat. And you can find a YouTube video of him making that speech and actually saying that when he received that award. And I just want to point out, this is Jim Floyd. He's born in 1914. This is him in 1950. This is him when he received that award in 2009. I was trying to find him 4 or 5 years ago. I wanted to nominate him for the AIAA Guggenheim Medal, which is an extremely significant aerospace award, because I couldn't find an obituary. I'm like, okay, he would have been 103, 104, but maybe he's still alive. And I could not find him. And I solicited some help from some people on this side of the border. So I was actually going to challenge you. I was going to say, my God, the man has got to be deceased by now. And yet there's no obituary. That's a travesty. But I found a Facebook page maintained by some Avro zealot that, I don't know, 8, 9, 10 months ago, it said Jim Floyd is still alive. He's 108 years old, 108 years old, which is incredible. If he still is, I really hope that's the case. And when he does pass on, you guys need to make a big fuss, because he's probably the greatest, aero engineer, aircraft engineer in the history of Canada. I'm going to give the last word to John Hodge. So I had the good fortune to interview over the phone before he passed away several years ago. This is the loads engineer that went to work for NASA, the flight director. And I said to him, how was Avro Canada able to do this, to go from making this in 1945 to this rolled out in 1957, flying in 1958? And he hesitated for a second and he said, he just said, come on. We didn't know we couldn't. We didn't know we couldn't. That was just the spirit of these young people working at Avro Canada at the time. And that's all I got. That's my last picture. I just learned again, preparing for this talk, I thought this is a great photo. This is not 205. It says 205, but it's actually 201. People were disappointed because 205 only flew once for 0.7 hours, that they took this photo of 201 and retouched it so it would say 205. They say, look at the last arrow flying. I guess, yeah, I guess they would have had to, I think that's it. Come on. Yeah. I hope I didn't offend anybody. I try to be as objective as I can, and happy to take questions with the limited knowledge of the Arrow that I have. Yes, sir.
So it's admirable for Americans to know so much about our trading. But in the United States, P-58, 9 Tesla, B-17, and the SSD 2707, they were scrapped, just like that. And what about the effect in the state?
Well,
Walter, can you repeat the question?
okay, the question was, the Arrow was, that's a great point, thank you. The Arrow was scrapped here, but in the US, you canceled the B-58, you canceled the B-70, and we canceled the, I don't know the number, but the Boeing supersonic transport. And there, of course, were for great setbacks. I mean, that period of time when the SST was canceled, there was a big billboard in Boeing. They were laying off so many that it said, will the last person to leave Seattle turn off the lights? The B-70 was, and the F-108, I talked about the F-108 that was canceled. The B-70 was North American. And North American aviation out in California was really, really hurting. And some people say because they laid off so many people due to the cancellation of the F-108 and the B-70, that was the reason they were awarded the Apollo capsule instead of McDonnell aircraft in St. Louis. Because on Mercury, very successful, Gemini, very successful, McDonnell built the capsules, and everybody assumed that McDonnell was going to get the Apollo capsule. And all of a sudden it goes to this airplane company out in California that never built a capsule before. And a lot of people believe that's what led to the Apollo 1 fire, that they really did not have their act together. And the reason that the Apollo 1 fire that killed Gus Grissom, Ed White, and Roger Chaffee in 1967 was because North American was given this job and they were just not up to it. So there were ramifications. There were ramifications.
I have a question from Zoom, exactly, Zoom world. Yes, this is a question from Jim Storchik. And he says, this is the first time I've seen a letter recommending scrapping. Where did you obtain the document?
There's a Canadian archive, government archive website that has where I got a lot of this stuff. The classified minutes from the Diefenbaker cabinet. I'm pretty sure that document, and I think even the radio recording are all, it's like archives.something.ca. I don't remember the exact URL, but they are publicly available online. Yes, sir.
Yeah, I assume those cabinet documents were only made public about 50 years after the fact. I believe that's how long they're kept secret for. I don't know that for a fact.
I know they were kept secret for a while because John McClinn, who made that statement in his book in 1967, they were still classified secret at the time. I tracked down McClinn. He lives in Switzerland. And I said, how did you know this? And he said, you know, it was just obvious. When he lists his reasoning, he had not read those cabinet documents yet.
My question.
Oh, and of course, the question, I should have repeated the question, was presumably the cabinet documents were kept secret for a long time.
Yeah. My question actually was going to be about the technology. I mean, there've been a lot of people over the years who said that the Arrow was so far ahead of its time and all those things. And but I remember seeing a presentation, I believe a CASI presentation by a guy called, I think it was Peter Zurin, who made the case that it was of its time. You know, a lot of the technological aspects of the airplane, other manufacturers in the US and the UK and elsewhere were doing similar things. Just that particular airplane at that time incorporated them all, and it was sort of leading the way, but that it wouldn't have maintained its lead for many more years. That's the point he made. How do you feel about that?
Okay, so the question is, a lot of people think the Arrow was way ahead of its time, but Peter Zuring, who's published a number of very good books with incredible photographs, I don't know where he got his photographs from on the Arrow, said it wasn't really, you know, maybe it put it all together, but it wasn't going to stay advanced. That's a great question, and in my opinion, the Arrow, from a technical and performance standpoint, is pretty comparable to the F-4 Phantom, which was its peer. If you look at first flights and so forth, I think the F-4 wasn't fly-by-wire. I saw no fly-by-wire for a long time, but so far as the technology of the avionics and the radar, the J79 engine that GE made at the time that was in the F-104, and it's smaller than the Iroquois, but a hell of an engine. So I don't think it was more advanced than anything else in the world. I think it was comparable to what at the time, it wasn't McDonnell Douglas, it was just the McDonnell F-4. But McDonnell was making airplanes for a long time, and it had the power and the funding of the US government behind it. Again, to me, the incredible part of the Arrow is after World War II, you have 400 people left in Victory aircraft when it's sold to AV Row in Canada. There's nothing there. And then they stand up this incredible engineering and manufacturing organization that 13 years later rolls out an Arrow. I think that's the true incredible part of the story.
I don't exactly have a question, but can stand up to the redundancies, the layoffs that took place. I worked for Doughty, the landing gear manufacturer for the Arrow and for the TSR-2, incidentally. They had 450 people employed, and then the next day they had 90.
Yeah.
And when I joined them in 1979, they had 95. And I think it's well over 500 now. So
yeah.
So it's just very dramatic. And the other thing I would say that from a landing gear point of view, this was an extremely long and lengthy and skinny landing gear to accommodate the engines. It didn't exist before. Everything else was short and stubby.
Yeah.
That thing was very long, 14.5 feet, I think.
Yeah. Yeah. So the statement was how much Doughty was in fact affected, who made the landing gear for the Arrow and the TSR-2, much like Avro Canada, but on a smaller scale. And you're saying how long the landing gear was. One of the things they do talk about in the Arrow movie that's true is they were trying to figure out how to fit the landing gear into the wing to reach down to the ground. And they gave the airplane a little anhedral, and that made enough of a difference. However many inches that bought them, it let the landing gear work. It let the landing gear work.
Walter, the chat questions are coming in now, fast and furious. All right. Jack the Mill is asking, is there a resource to learn more about the intermediate designs like CF-103? I can't find any books with good drawings.
CF-103 is ringing a bell, but off the top of my head, I can't tell you anything about it. So I can't offer anything there. One thing that I have found is very handy, and this is kind of cheating in my research on the Arrow and a number of other subjects, is to go to the Wikipedia article, not for the article itself, but for the references. Sometimes the references are enormously helpful as a point to start your research if you don't know where else to go. And if there's a Wikipedia article on the 103, even if he's disappointed with it, I would say go to the references and see what they're referring to, and you may be able to find out, probably will be able to find out a lot more.
Another question. This is from Fortin F. Is there a way to, has anyone confirmed that the 2G turn at Mach 1.5, 50,000 feet was possible?
I can't quote the reference where I've read it, but I believe they, and it wasn't 2 Gs, I think it was 1.5 Gs, wasn't it?
Okay.
Yeah, well, if it's 1.5, if I'm remembering correctly, it sticks in my head that they demonstrated 1.49. Or if it's 2, I thought it was 1.5, but if it's 2, they got extremely close to it. They basically satisfied the requirement by 1/100 of a G was my recollection that was demonstrated. And that's in one of the books, maybe one of those books. Yes, sir.
Hi, so I work at the National Research Council, and through conversations with I'm not an aerodynamicist, but with some colleagues in aerodynamics who I guess inherited a bit of the word of mouth oral history. There's a belief that there were stability and control issues with the aircraft, perhaps around the transonic region, that would have made it, and in the words of a respected colleague, ex-colleague, there would have been, the attrition rate on that aircraft would have been fairly high as a result of these stability and control issues, I guess, with the shock wave. Is there anything in your research that indicates that is maybe true?
So the question was, a gentleman worked at NRC speaking to some aerodynamicists there who are talking about lore or things they heard from older people and so on and so forth, was that the Arrow may have been exhibiting stability and control problems, particularly in the transonic regime. I can't talk to that specifically, but I will say sort of peripherally in one or both of those books and some of the other books, inspecting the flight logs, they're not even logs, they're like little capsule descriptions of each flight. They talk about some stability issues. I don't recall if they were transonic, and that they were addressed over time over the flight test with the damping and the fly-by-wire system. But whether, after a 70-hour flight program, were they addressed to satisfaction? Woodman's statement that I thrown up there seemed to imply that they were, but I'll also throw out, 70 hours is nothing, so with the fly-by-wire system, even if they were exhibiting problems, I'd say they perhaps would have had a good chance of getting over them if the analog computing available to them at the time was up to it, which perhaps it wouldn't have been, because it was a very simple analog system. I don't think you asked one yet, sir.
I'm also from the National Regions Council, and I have J75 engine in my possession, which actually flew on Canberra.
Really?
I'm trying to get rid of it. I gave the one that the museum had, I gave that one to them. And we actually were testing the Iroquois engine in our facility when the program was canceled, and we ended up disobeying the order to cut it. And then we hid it for a while, and then we donated it to the museum. So
And that's the one that's in the
that's
museum?
one.
Yeah. Oh.
We gave them what we offered them the 2 J75, and they would only take one, so.
Yeah. The people out in Zoom, just a gentleman here from NRC said that they still have a J75 in their possession that flew on the Arrow. And if there's anyone watching from another museum that would like that, maybe contact NRC.
I think I worked with Jim. I think if you look at, I don't know what the Iroquois was at the museum, we can see the damage that was done. They took a cutting torch to the turbine casing and to the compressor casing and just cut out a hole in each of those areas.
Render it inoperable.
Right.
Yeah.
Another Zoom question, and apologize if there's feedback on my. This is from Sean L. His question: the Arenda was its own innovation success. Why did it survive the killing of the air?
Or any other company, I think, so.
Yeah, I guess. Maybe the question is what happened to Arenda, the engine, and Arenda, the company.
Well, they made 4,000 Arenda engines. They were in the CF100 and the F86.
Yeah.
The Iroquois, like I say, that was canceled. They were cut up, and all the Arenda employees were laid off the same day as the Avro employees. If the vestiges of Arenda were more successful than the vestiges of Avro, I can't really talk to that. I don't want to make up an answer. Yes, sir.
Arenda also made derivatives of that for industry. So the company probably survived through the industrial applications that had previously been done on Arrow.
The derivatives of the Arenda or of the Iroquois?
The other Arenda engines.
Yeah. The statement made was that Arenda made industrial derivatives of their engines, of their turbines, and that would have helped them survive. Sir.
I'm not aviation engineer, so my question is type of lay question, but I'm space engineering right now. I'm working with David Florida Laboratory here, testing spacecraft and satellite. Anyway, I just like to know if the test program for Arrow was so advanced that it led to the successful first flights, or it was still not too good to prove the same aircraft. This is first question. The second question is, any heritage of Avro is still living in some designs of some planes in UK or in the US.
Okay.
So it's a lay question. So
Yeah. Well, and I'm not a test engineer, so I'm probably going to give you a lay answer. But so the question was, did the test Arrow play a significant role in its success of the aircraft? And I can't give you a comprehensive answer to that, but one thing I can say for sure is it's my understanding that the extent of the employment of telemetry on the test program was also world leading at the time in the Arrow, rather than just recording a limited number of things and then looking at them afterwards. You had many more signals being broadcast in real time to the ground. And I think that would have made the test program more effective. I have also read that the telemetry equipment was very cantankerous, but that would probably follow. But in that respect, I think the test program was very significant. Yeah. Great question of Arrow living on today. When I first gave this talk at SciTech, AIAA SciTech in San Diego, when the Canadians did not know who J.A.D. McCurdy was, Paul Bevilacqua came up to me afterwards. And for those of you who don't know, and he gives a fantastic talk to AIAA. You guys should try and get him for CASI. He's considered the father of the F-35. He was an engineer at the Lockheed Skunk Works, and his main contribution was the lift fan. which is the biggest reason why Lockheed won it rather than Boeing. But in general, he's considered the father of the F-35. He comes up to me afterwards and he says, Walter, you know, we examined the Arrow in great detail when we were trying to design what the F-35 was going to look like. And I was like, really? How? You know, and he said, the high wing and the square fuselage and the internal bomb bay, which the F-35 had to have because it's stealth. We looked at all of those features on the Arrow and how they were implemented in coming up with the design for the F-35. So I can answer with respect to that example. Yeah.
Thank you so much. A related question from Alex Nielsen asking, do you think that the Arrow design influenced the F-106?
I don't know, but I don't think so. They were essentially parallel developments, and the F-106 was basically an improved version of the F-102, and the F-102 was flying long before the Arrow. So now the F-102 was the first airplane to employ the area rule to get past Mach 1. So if Jim Chamberlain invented it, maybe that's the Arrow connection. Yes, you had a question.
Yeah, you mentioned Skunk Works a minute ago, and it reminded me something I read in Kelly Johnson's book, where he talked about developing the SR-71 in the absence of supersonic wind tunnels to refine the aerodynamics on that, test them. So they did this rocket program, much like what was done on the Arrow, which would have been a few years later, I think. When he writes it in his book, it comes across as being a novel approach to things. And I was aware that Avro had done it with the Arrow, but I don't know if it was done by other companies as well. Do you know about that?
So the question was, in Kelly Johnson's book, he talks about doing similar captive boosted flights with SR-71 models like were done in the Arrow. Do I know of any other examples? I can't give you a specific answer, but I have a vague recollection of someone doing tests like that off of Wallops Island for something. So boy, I couldn't wave my hands more than that, but I don't know of any specific examples, no.
One more Zoom question from Jim Sudorchuk. He asked, he recalls after cancellation, a request was made by the UK to obtain the aircraft for research purposes. Was this actually the case, and how was the request made?
I have read that also. I don't have to repeat it. The question was from Zoom that the UK requested one for research purposes, and supposedly the Canadian government turned them down. But how real was the request? How much money was there behind it? And what would have been the UK's ability to keep up and maintain this one-of-a-kind aircraft with no logistics tail? That would have been challenging. But a lot of people are talking about that. You know, why weren't they cut up? Some people say that the US Air Force wanted them, that they wanted one out at Edwards, and the Canadian government said no. I've been unable to corroborate any of this with specific documents like I have with some of the other stuff. It's certainly possible. It's certainly possible. Yes.
If I gave you a magic crystal ball and it can answer one question about the Arrow, what would your question be?
Oh, boy. Answer one question about the Arrow. Why did you cut them up? Why did you, I mean, it's not a technical question, but why did you cut them up? And one answer that's actually given for that is they say, and again, I have nothing to back this up, but some people claim or speculate, I don't know which, that Avro, like many other companies, was infiltrated by Soviet spies at the time, and that it was advanced technology, you know, aerodynamically and from an engine standpoint, and they didn't want any chance of it getting back to the Soviet Union. And I know a Bell aircraft in Niagara Falls, where obviously I'm a little closer to that. That's a fact. There were Soviet spies at Bell. So perhaps there's something to that.
Yeah, one last question.
Yes, ma'am.
But from your personal perspective, in your opinion, and what you know about the whole story, if that team was present today with today's technology, what do you think they would need to accomplish?
Oh, God. Well, the key besides the team and the ability and the technology is like they say in the movie, The Right Stuff, no Bucks, no Buck Rogers. So you need the money behind it, but my personal thing, and Avro was actually looking at this in the late 50s. I would like to see them do a single stage to orbit launch vehicle. And Avro was looking at that. I think that would be pretty cool. The fact that the US right now on the Space Launch System is basically reinventing the Saturn V. As an engineer, I find extremely disappointing. Elon Musk's approach is better, and I'm not much of a rigorous aerospace engineer anymore, but I'd like to see something with wings take off horizontally and convert from scramjet to ramjet to rocket and go up into orbit. And they were looking at that. They were. If you look at the Jim Floyd video, which you can find on YouTube, he actually alludes to that. Yeah, and if not single stage to orbit, then just a suborbital hypersonic vehicle, like Toronto to Tokyo in an hour, something like that.
Any last questions? Okay, thanks. Well, thank you, Walter. It's been our pleasure. I can't believe your microphone.
There, yeah.
Thank you. Just on your behalf and on behalf of the people online, we'd like to thank Walter for coming all the way up here and for, I think, a lot of very interesting talks that AIAA has made available to people in this area. It's probably a toss-up. We should maybe look at sort of combined CASI AIAA memberships for people in the Ottawa area, but we'll, times are tight and there's lots of interesting subjects and lots of people that we'd like to engage and inform, and there's continuing new generations of students coming up that we would like to involve and encourage and take their enthusiasm and keep it going in this community. So I'll thank Walter on our behalf for a wonderful talk. He didn't come with an AIAA tie, but we'll send him away with a CASI tie so he can do advertising for us whenever he does his talks in the future. So it's three geese flying kind of in the same direction.
Okay.
I don't know what this is about Canadian engineering, but
This is terrific. Thank you.
and Omer.
So noted that you are an amateur aviation historian. I bought this book because it's my favorite and it's a great story. You might already have it. It's the biography of the Wright brothers.
I have read it. I don't have it. I don't have it.
So you will accept it.
Oh, my, yes.
Okay,
Yes.
all right, because I had an alternate, like all good pilots, which was Kelly Johnson's biography. So
Oh,
yeah,
do
so
I have to pick?
you do.
Oh, why?
So
I think I own this one on Kindle.
yeah,
I think I own this on Kindle, but I don't own this at all. So I'll take Kelly.
done. All right. So again, thank you very much. And there is a museum visit planned for tomorrow. In terms of the timing, do you want to speak to that?
Yeah.
Sorry.
So a lot of people have probably been to the Aviation Museum. There are standing tours on tomorrow. And anybody who's willing to go, and maybe we'll do raise your hand if you're interested. I think Walter and I were going to go. There's a general tour available either at 10 or 10:30 tomorrow morning. That will go around the museum in general. Walter's willing to be there, but he's not going to try and out-talk the guide that's there. But you could either come for that, or in addition at 11:30, there's a tour that will go into the storage hangar. So we'll probably be there for both of those. So not only would you see the wings and the
jetliner nose section,
but I think there's a lot of other pieces in that hangar that a lot of people don't necessarily get to see, and it's not widely available. So We'll be there, and anybody else who's willing to come. There's no special rate unless we could get, it's too late to put a group together, but anybody who's interested, raise your hand and we'll just keep an eye out. So maybe 3 or 4, so, or 5. Okay. The students are not still doing assignments, or we can get a waiver on when they, on the due date, Catherine, they can hand stuff in an extra day later. Okay, so,
One other question. Jeff, do we have a budget for a tie and 2 books?
oh, I'm sure we do.
Yeah. I didn't mean to put you on the spot, but yeah. You did drive all the way from Buffalo. And his bag as well, we spared no expense. 25 cents, yeah, so.
Even just that you got it in a bookstore, they're harder and harder to come by,
Absolutely.
so.
So
Yeah.
for the people who are here, there, I think there's a few more desserts and there's maybe some lukewarm coffee there. Please stay around and chat. There's lots of very interesting meetings here between the airworthiness people over on this side and the energy people in the center here. And the enthusiastic students are all over here. They're all looking for jobs, better jobs than the ones they've already accepted. So if you have an idea for even biomedical people, we don't discriminate against them, against mechanical engineers. Engage with one of the students and talk to them and hang around. We're happy to keep it going. And for the people online, thanks for your support, and we're talking about other events in the rest of the year. Perhaps we'll follow through with Alex on a tour of the David Florida Lab in June. So keep an eye out for that. It'll either be in June or we can't do it then. We'll try and do it early next year.
We can early next year would be better now.
Okay.
You mentioned about McCarthy flight. You know that Bjarni Tryggvason, my old friend who passed away in 2019, he flew Silver Dart replica
On the anniversary.
on the 100 years anniversary of the first flight.
Yeah.
Of Silver Dart. This was something.
Yeah. I just want to point out something quick to the people on Zoom. I guess it's still up there. My wallpaper, that is the Avro Canada plant in Malton in 1958 when the Arrow was made. In fact, if you look on the roof of one of the buildings, you can see AVRO Canada.
Right.
Yeah. This is.
Yeah. And yeah, thank you to CASI headquarters, Todd, who supported us remotely on the Zoom this evening, and April, who took the registration, set up the announcement, and Jeff, the executive director. So thanks to the CASI headquarters staff and all of you online and here. Those of you who came out in person, it's fantastic. First dinner meeting in 4 years. So thanks for making the effort. This is a great restart to our dinner meeting. So yeah, thanks again.